In this video, we'll look at the Heathkit RX-1 Mohawk Deluxe Amateur Radio Receiver. We'll look at the history of the radio, its features, and take a look at it inside and out. I'll discuss the restoration of this particular unit and demonstrate it being operated. Heathkit was well known as the premier manufacturer of electronics in kit form from the 1950s into the early 1990s. Their product line included shortwave and amateur radio equipment. The RX-1 Mohawk was a high-end amateur radio receiver introduced in 1958 at a price of $274.95, equivalent to about $2,200 today. It was sold until 1964. This 1961 Canadian Heathkit catalog lists the Mohawk at $349.95, with the matching AK5 speaker for $13.95. It was Heathkit's first ham band only receiver and one of the first high-end communication receivers to be offered in kit form. Heathkit offered a matching TX1 Apache transmitter, which had an almost identical appearance and supported transmitting with AM voice or CW Morse code on the same bands as the transmitter. This was during the era when Heathkit named most of its amateur radio equipment after Native American Indian tribes. The RX-1 and TX1 were the first units to feature the classic Heathkit green color. The RX-1 is a tube-based amateur radio receiver. It weighs in at about 52 pounds and covers the following frequencies in 7 bands. 160 meters from 1.8 to 2 MHz, 80 meters from 3.5 to 4 MHz, 40 meters from 7 to 7.3 MHz, 20 meters from 14 to 14.35 MHz, 15 meters from 21 to 21.45 MHz, 11 meters from 26.96 to 27.23 MHz, 10 meters from 28 to 29.7 MHz, 6 meters from 50 to 54 MHz, and 2 meters from 144 to 148 MHz. You may recognize 11 meters as the Citizens Band. Prior to 1958, it was allocated to amateur radio. The other bands are all still allocated to amateur radio. Reception on 6 or 2 meters required an optional add-on converter, either the model XC6 or XC2. The radio's features include the following: amateur radio band coverage only, a built-in 100 kHz crystal calibrator, adjustable selectivity of 5, 3, 2, 1, or 0.5 kHz, a bridge T notch filter providing up to 50 decibels of rejection, automatic noise limiter, AF, RF, and IF gain controls, a product detector for receiving CW and single sideband signals, and a large S meter. The design uses 15 vacuum tubes. It runs on 117 volts AC and takes about 75 watts of power. The tube lineup is the following: 6 BZ6 RF amplifier, 6 SC6 first mixer, 12 AT7 oscillator cathode follower, 6 BA6 IF amplifier, 6 CS6 second mixer, 12 AT7 crystal oscillator, 6 BA6 IF amplifier, 6 BJ7 detector AVC and automatic noise limiter, 6 SC6 product detector, 12 AT7 first audio and S meter amplifier, 6 AQ5 audio output, 6 BA6 100 kHz oscillator, 0A2 voltage regulator, and 5V4 rectifier. It's a dual conversion superhet design with a first IF frequency of 1682 kHz and a second IF of 50 kHz. Sensitivity was listed as less than 1 microvolt for 10 decibels of signal-to-noise ratio. It can be aligned without test instruments. The front end, consisting of coils, band switch assembly, and some tubes, was factory assembled and aligned. Like most Heathkit products, it was sold only as a kit. Let's take a look at the front panel. At the top right is the dial, which rotates to show the appropriate band. At the top left is the large S meter showing signal strength in S units and decibels. The front panel controls are switches for A&L on-off, AVC on-off, and AM or CW single sideband mode, BFO tuning, notch tuning, lower sideband, upper sideband selection, standby receive switch, crystal calibrator push button, a large main tuning knob, dial calibrate control, and antenna tuning. Power and AF gain, RF gain, notch filter on-off and depth, IF gain, selectivity or bandwidth selecting one of 5 positions, band switch selecting 160, 80, 40, 20, 15, 11, or 10 meter bands or optional 6 or 2 meter converter, and finally a 1/4 inch headphone jack. There's no built-in speaker. You could use any 8 or 500 ohm external speaker. Heathkit offered the matching AK5 speaker. Reportedly, running the unit without a speaker can damage it. Plugging in headphones disables the speaker. The knobs are solid aluminum. Early knobs had a satin finish. Later they were switched to polished chrome. This unit has the satin knobs. On the rear panel, the connections are from left to right. The SO239 antenna connection, screw terminals for 50 to 75 ohm unbalanced coax cable connection, or 150 to 300 ohm balanced such as twin lead antenna connection, terminals for 8 or 500 ohm speaker, an octal accessory plug for B+ and 6.3 volts AC filament voltages, mute and AVC, the line fuse, a 2-prong accessory plug, and the line cord. Removing the cover, we can look at the top of the chassis. 2 support brackets keep the front panel rigid. Visible are the power transformer, filter caps, tubes, variable capacitors, and IF transformers. The large tube is the 5V4 rectifier. This one, the 0A2 regulator, normally has a purple glow in operation. Some tubes are shielded. The 100 kHz crystal looks like a tube and is shielded. I've never seen one like this before. This portion is the factory wired and aligned front end. The front end chassis has many adjustable caps and connects via 2 coax cables. Under the chassis is most of the wiring, which is point-to-point. The design uses a factory-assembled wiring harness to reduce the assembly effort and likelihood of wiring errors. I bought this radio in September 2014 on Kijiji from a seller in Ottawa, Canada. They said it belonged to their grandfather, who was an electrical engineer and a member of some local radio clubs. It was very dusty but looked complete. I needed help carrying it to the car. It didn't come with the matching speaker. I suspect not many people opted for the speaker, as any standard one could be used, and the official Heathkit model sold for the equivalent of over $100 today. I found a full copy of the manual on the internet. The manual is about 70 pages in length and has Heathkit's typical detailed instructions with steps to be checked off. It includes voltage and resistant measurements and troubleshooting hints. I also found an additional manual that gives the instructions for aligning the front end tuner assembly in case the user wants to align it themselves rather than relying on the factory alignment. Restoration started with removing the case and spraying it down with water and drying it in the sun. I cleaned the knobs with soap and water and oiled the set screws and associated controls. I cleaned the dust and dirt from the chassis using a paintbrush and small vacuum. The chassis is so large that it wouldn't fit on my usual workbench. Initial inspection and testing showed that the line cord was open. The line cord was old and brittle and had an intermittent break near the plug. I replaced it with a modern, heavy-duty 3-prong grounded cord. I then performed an initial power-up test, powering it up slowly with a variac and a current meter. As the voltage ramped up, it came to life and seemed to be working. The electrolytic filter capacitor seemed to be okay. There was no hum, and the ESR measured okay, so I left them in for now. All power supply voltages were very close to the nominal voltages listed in the manual. The pre-assembled and aligned front end meant that the radio did not need any instruments to perform an alignment other than the built-in S-meter and crystal calibrator. I went through the test and alignment procedure. The procedure requires temporarily adding some trimmer caps. My unit still had them tucked into the chassis in an envelope. I did not do the optional alignment of the factory-assembled front end, but will probably do so at a later date so that the dial calibration is bang on. This might be a suitable topic for another YouTube video. Note that the instructions state that you should place the chassis on a sheet of metal during alignment, since removing it from the metal case affects the tuning. Let's listen to the radio on the air. I have the radio connected to my amateur radio dipole antenna. It's afternoon here in Ottawa, Canada, and we should be able to pick up a few signals on the 20-meter amateur radio band. For AM operation, such as shortwave broadcast station reception, you can set the mode to AM and typically want AVC on. AF gain is adjusted to a comfortable level, as well as RF gain. The widest selectivity setting of 5 kHz is usually selected for best sound quality unless the bands are crowded. The dial calibration can be set by turning on the VFO and adjusting the dial to a 1 kHz setting point, pressing the calibrate button and then adjusting the calibrate control to zero the signal. There aren't very many AM signals on the amateur radio bands these days, particularly not in the afternoon. So we'll look at some single sideband voice and Morse code or CW signals. So typically the antenna trimmer needs to be adjusted for maximum gain. For CW or single sideband signals, you set the mode to CW SSB, select upper sideband or lower sideband as appropriate for the band, and adjust the BFO for the correct pitch of the signal. Usually for single sideband, the BFO can be left at the position of the small triangle. Selectivity of 3 kHz is usually best for single sideband, while narrower can be useful for CW. For strong signals, the RF or IF gain controls may need to be backed down. So let's see what we can find on the 20-meter band today.
3, 2, 1, we're on ya. How copy? Okay, now with that pointed the right way, you are also 5'9". Copy 5'9", 5'9" here in New Jersey. Did you hear this today? We are experiencing some cold weather.
At the lower part of the band, we should hear some Morse code signals. So this is actually radio teletype. The notch filter can be useful for notching out or canceling unwanted nearby stations. The notch depth control turns on the filter and adjusts the depth of the notch. The notch tone control controls the frequency of the filter. Operation requires some practice, but this can be very useful when receiving Morse code signals. I need to do some more testing to confirm if the notch filter is properly working and adjusted on this unit. Old radios over about 30 pounds in weight are often called boat anchors. This one definitely qualifies for that name. A heavy and mechanically solid case was an important factor ensuring that a tube-based radio like this was stable. A ham radio station consisting of an RX-1 receiver, TX1 transmitter, and various other accessories would have needed quite a large and solid desk to sit on. The RX-1 was marketed as a deluxe receiver and included most of the bells and whistles that a radio of this era could provide, and the price reflected that, selling for the equivalent of more than $2,000 today. This is quite an early radio, and surviving units are said to be relatively rare. The XC6 and XC2 converters and AK5 speaker are even more rare. The model was replaced by the Heathkit SB300 in 1963. Thanks for watching. If you enjoyed this video, check out my other YouTube videos on vintage amateur radio and test equipment.